We're going to solve by graphing, and then tomorrow I'll remind you of the familiar solve by elimination, solve by substitution. Remember that stuff from your first algebra class? Yeah. This is really important though, but it's not important for what we're doing. That happens a lot in math, you guys. What we're doing right now, the method for solving this system of equations is much easier using, say, elimination or substitution that you learned about previously. But solving by graphing is important for ones that you don't know how to solve by hand, when the equations are more complicated. So that's why this method's important. Okay, so basically you're going to get a review, at least at first, of graphing a couple of lines. So let's take the first equation, 3x plus y equals 5, and what do you suppose would be the best way to graph this thing? There's a couple different methods we've talked about. I agree with you. Let's put it in y equals mx plus b form and graph it using the shortcut. So what would I have to do to get y by itself? So 3x. Subtract 3x from both sides. I'll do it vertically. Except on the right side, how do I write it if I want to put it in slope-intercept form? Yeah, it would work as 5 minus 3x, but it wouldn't quite be in slope-intercept form. So another way to write it is negative 3x plus 5, right? So what do I get from that equation? That helps me out a lot. The slope, what's the slope? Negative 3. If you want, you can think of it as negative 3 over 1. What's the y-intercept? Yeah, the y-intercept is 0, 5. So that's a good place to start. I recommend when you're doing your homework, do it on graph paper and use a straight edge. Get a ruler and use a straight edge and graph paper. You can Google image, do a Google image search for graph paper, and you'll get a whole bunch of options. You can print it up. So I'm going to plot 0, 5. I guess what I'm trying to say is you have to be pretty accurate here when you're in graphing. 0, 5. 0, 1, 2, 3, 4, 5. And then what do I do with the slope to get to another point on the graph? From a point on the graph, in this case the y-intercept, where do I go? Down. So you think of it as rise over run, right? You think of it as rise over run. So rise over run. So a rise of negative 3 means down 3. And for a run of 1. So go down from the point on the graph. 1, 2, 3. Go down 3 and over 1. Could you do it again? Yeah, you could go down from that point that I just drew. 1, 2, 3, and over 1. Now, when you're drawing this by hand, this is when you take out your straight edge and draw a line through those 3 points. Now, I can simulate that on my computer by the line tool. And you do want to be very exact. You're not just sketching a graph here, you're looking for accuracy. So you want to be very exact and make sure it goes through all 3 points on your graph paper. Pretty good. So that line in blue then is our first, the graph of our first equation. Okay, that was cool. I can shrink this down a little bit. Don't you wish you could do that with paper? Someday they're going to come out with paper you can do this on, I bet. The paper will be your screen. And I know they have some stuff now, but I mean, this is my vision, stuff the thickness of a piece of paper, maybe a little stiffer. And then that's your screen. You can write on it, shrink it. That's going to be, that'll happen in your lifetime, maybe not mine. Okay. So now let's take the second equation, x minus 2y equals 4. What would be the best method to graph x minus 2y equals 4? Good. So she's talking about finding the x and y intercepts. So basically, you're plotting a couple of strategic points, the x and y intercepts. So you can make a little table here. If you plug in 0 for y, think about it. If you plug in 0 for y, you're essentially saying, oh, x equals 4, right? Because if you plug in 0 for y, this whole thing minus 2 times 0, that whole thing goes away, right? And so you can very quickly in your head plot the corresponding x value, which it turns out to be the x-intercept. What would it be? Well, I already gave it away, 4. Right? So when you plug in 0 for y, that's the x-intercept, isn't it? And then what's the other one you could quickly get? Yeah, so you plug in 0 for x. That means, oh, this guy's gone, and you have negative 2y equals 4. So what does y equal?
Negative 2.
Yeah, divide both sides by negative 2. And so 0 here gives you a negative 2 there. Does everybody agree with that? Yeah. And that would be the y-intercept. Okay, so I'm going to plot those 2 points, and I guess I'll do those 2 points in red. So, okay, so 4, 0, 1, 2, 3, 4, 0, negative 2, right there. Get my line tool, right there. I don't need to go any further, but I think I see it. You guys see what the intersection point is? It sure looks like it's right here. Can you tell what it is? Looks like it's 2, negative 1. Now, can you check that? I'm pretty confident with that because I used graph paper and I simulated straight edge, so I'm pretty confident with that answer. But yeah, you can check it, right? Just check it mentally, right? So if you plug a 2 in for x here and a negative 1 here, when you do the arithmetic, do you get 5? Yeah, 3 times 2 minus 1 is 5. And when you plug the 2 in here and the negative 1 in here, do you get 4? Yeah, you end up with 2 plus 2 on the left side, right? Which is 4. So you know that's the correct answer. You can always check your answers when you're solving equations or systems of equations. You can always check. But when it's systems of equations, you have to check in both. Any questions? Yes?
Can you use that same method on A?
Oh, you mean the technique for intercepts?
Yeah.
Well, that's a good question. The problem is you end up with fractions. You end up with one fraction. Look, when you plug in 0 for y, you end up with x equals 5/3, don't you? So if you tried to find the x-intercept for this one, you guys, and you plugged in 0 for y right there, you get 3x equals 5. Solve for x, you get x equals 5/3. So it works. You could plot it, but it's a fraction and it's a little harder to deal with. So when does the intercept method work? When it works, it's awesome. You guys saw how quick it was, right? It works when the coefficients of x and y, or whatever the variables are, divide the constant. So in the second equation, the coefficient of x was 1. You didn't see it, so it was 1. The coefficient of y was negative 2. They both divide 4 evenly. And so that's when solving or graphing using the intercepts will work best. Does that make sense? And so look for that because it is really easy when it works.